Current probabilistic AI models learn globally. They require massive statistical reconstruction across billions of continuous weights for every single query, and they inherently lack structural provenance. You cannot trace exactly how a conclusion was constructed. To solve this, the architecture you see here abandons probability entirely and snaps into a strict discrete geometry. This is Aurora version 1.0. It is a strictly discrete, self-similar, and homoiconic architecture. It rejects continuous values and probabilistic guessing in favor of verifiable local logic. The core thesis of this model is that data, search, memory, and control do not need to be distinct physical systems. In Aurora, they are exactly the same class of ternary structure, operated by a single, identical relational mechanism. We are going to build this architecture from the ground up. We will start at the atomic level with the TriGate circuit, scale up through the structural face, and finally arrive at the operative window to see how local relations generate global computation. By utilizing one unified relational mechanism across every level of scale, Aurora eliminates the need for separate external memory blocks or a centralized CPU to route information. The structure itself is the computation. At the base of the model is the trite, a ternary state space consisting of 0, 1, and 2. 0 and 1 are complementary determinations. 2 is not a numerical value. It represents an open, unresolved potential that remains when a relation lacks the context to close. This physical circuit is the TriGate. It takes 3 input nodes, an anchor A, a second operand B, and a mode M. After resolving the relationship, it outputs 3 variables: the result R, the emergent state EC, and the orientation O. The invariant rule governing the circuit is the ternary majority function. If 2 inputs match, that value wins. If all 3 are different, the output remains an open 2. The mode acts as a conjunctive or disjunctive bias, tilting the logic when the primary operands do not match. The system does not use 3 different algorithms to deduce, infer, or learn. Instead, you change the direction of resolution. You select a different target cell to transform, and the circuit computes the valid states that satisfy the overall relation. The output is a strict package. The result indicates whether the relation closed or remains open. The emergent state qualifies that coherence, and the orientation records where the system read from and how to proceed next. This atomic mechanism acts as a universal logic gate. When it encounters ambiguity, it outputs a 2. It holds unresolved potential perfectly intact, eliminating the need to force a statistical guess. Because the architecture is homoiconic, data, operations, and indices are physically identical. They are all structural triplets, meaning any unit can act as a command or a memory depending entirely on its position. Scaling up to the second level, we have the face. A face receives 3 triplets from the system window: admitted context A, context B, and an open query U, which begins entirely unresolved. In the ordering phase, the internal orientations of these triplets independently assign roles: structure, function, and form. The raw data dictates its own operative position within the face without any external instruction. The face then calculates the homologous coordinates and synthesizes a new triplet: knowledge. This knowledge is a stable photograph of the relational state, packed into the exact same structural format, ready to be applied at the next time step. This self-similarity ensures the network organizes its own raw data into functional pathways natively. There is no central supervisor parsing the data and routing it to an execution unit. At the third and fourth scales, we reach the transcender and the window. Here, 3 faces group together. Local operative seeds pulse at the base, reporting up to a single window operative seed overseeing the boundary. There is a strict separation of computational duties here. The local operative seeds do the heavy lifting of constructing the state. The window seed never alters that state. It acts strictly as a gatekeeper, deciding only how the structure propagates. Propagation is governed by a canonical transition table. If the window seed registers a coherent closure, it triggers vertical emergence. The constructed structure ascends directly into the higher hierarchy. If it registers an incoherent closure, it forces a horizontal shift. The window refuses to force a synthesis between incompatible tensors. The original context moves up alone, and the window slides over to evaluate the next incoming data. If the relation remains entirely open, the state is transported intact. The unresolved query is passed forward to the next window as a literal carry, preserving every nuance of what is missing. By isolating the mechanical construction of the state from the decision to move it, Aurora scales hierarchical complexity seamlessly. The base relational math never changes, only the type of unit occupying the space does. The dictionary in this architecture is a strict repository for admitted, verified tensors. It is an active participant in search, not a passive memory block holding detached strings of text. This introduces the absolute negative constraint of the system. If a search fails to find a match in the dictionary, it is physically blocked from creating a new tensor to fill the gap. The open query is a transient progressive index, mapping the boundaries of a missing fact. It is not a generative prompt. The system searches for exact geometric compatibility, and if it fails, it accepts the failure. Instead of hallucinating a probabilistic answer, the carry mechanism takes over. The unmatched query is packaged as a carry unit and transported horizontally. The system keeps looking, carrying the exact shape of its ignorance forward. Knowledge can only enter this dictionary through a verified explicit admission event from a closed relation or an external input. The architectural refusal to invent data upon a search failure is the mechanism that guarantees strict provenance. Every piece of knowledge in the dictionary is traceable, tested, and structurally sound. This creates a closed operational loop at every level of scale. Order the units, relate the coordinates, project the emergent state, re-execute to verify, and either emerge vertically or carry horizontally. In execution, the global architecture is made up of thousands of relational automata executing this exact ternary loop in parallel. There is no central processor taking in variables and translating them into instructions. The physical propagation of structural changes through the lattice is the global coordination. Because execution is distributed locally, computational cost is isolated entirely to regions where state changes actively occur. If the local operative seed registers no change, it emits no event, locking that region's energy footprint at zero. Probabilistic models map inputs to outputs by averaging the weights of massive datasets. Aurora learns strictly through local geometric closure. It reuses verified knowledge directly and refuses to guess when context is missing. By constraining intelligence to precise, discrete ternary relations, this architecture offers a rigorously verifiable, structurally transparent foundation for artificial computation.